This video will be on section 6.1, higher degree polynomial functions. A cubic function in the variable x has an equation in the form ax cubed plus bx squared plus cx plus d with a not equaling to 0. A not equal to 0 makes sure I have a cubed term. It is a characteristic of a cubic function to have a graph that has n behavior as it goes to positive infinity or negative infinity that can be described as one end opening up and one end opening down. Our basic y equals x cubed function looks like this: one end up, one end down. The specific end behavior is determined by the leading coefficient. That means the coefficient of the third degree term, in this case the a. The curve opens up to the right if the leading coefficient is positive, and down to the right if the leading coefficient is negative. If its leading coefficient is positive, it opens up to the right. It's going higher to the right, positive. If the leading coefficient is negative, it will go down to the right, and that will be our negative, thinking going down. And in general, the graph of a polynomial function of any degree n has at most n x-intercepts. The graph of a cubic function will have 0 or 2 turning points. 0 turning points, it might look like this. This might be 2 turning points. The turning points are called local extrema points, extrema being talking about minimum or maximum points. In particular, a point where the curve changes from decreasing to increasing, decreasing to increasing. So that might be about right here where it changes. That will be a local minimum point. And where it changes from increasing to decreasing, which might be about here, going left to right, that would be a local maximum point. It's not a total minimum or a total maximum because, of course, you can see these go to infinity. We're going to use an appropriate viewing window to graph y equals x cubed plus 2x squared minus 8x. And we're going to find the local maximum and local minimum, if possible. And where's the absolute maximum of this function in the interval from 0 to 3. Our equation, our standard window, let's make it the standard, negative 10 to 10, negative 10 to 10. That's always a good place to start, and then we'll see what happens with that graph. Oh, for this graph, we can only see one of the turning points. There's another one up there, but we can only see one of them. So we need to extend our window. What needs to be higher on our window is the y maximum. Let's try 20 and see if that works. It does. Now, they ask us to find the local maximum and local minimum points if possible. Going to find those through second CAiC, and first we'll go for the maximum, and we can see the maximum, local maximum is here. We want a left bounded some number to the left of that point and right bounded a point to the right. So we'll go negative 5 appears to be on the left side. 0 appears to be on the right side. And then we'll take a guess at negative 2. We found then that our local maximum is negative 2.430501 and y equals 16.900. Let's do 2 decimal places. My maximum is at 2.43, 16.900. 9, 0. That's my local maximum. Now we'll have to go back and find the local minimum. To second calc, and now we're looking for our minimum. Our minimum left side looks like it's between 0 and maybe 5. We'll take a guess that it's at 2. It's at 1.097, so 1.10, and negative 5.049, so negative 5.0. I mean, it's somewhere, we're looking somewhere from 0 to 3, and we want to find the maximum value. So it's continuing to go up. So we're going to do second calc. We are looking for a maximum, and we're looking for that maximum between 0 for the left bound and 3 for the right bound. Here it is. It's right here, given this boundary. We're going to guess 3, and it is at 321. It was bracketed, so we remember that that will be the point. Our absolute maximum between 0 and 3 will be at 320. Now we're looking at quadric functions. This is a polynomial function in the form ax to the fourth plus bx cubed plus cx squared plus dx plus c with a not equal to 0. Again, a not equal to 0, so we have an x to the fourth term. It's a fourth degree or quadric function. The basic function looks like this. You might notice it looks like a parabola with a fatter bottom. This is y equals x to the fourth. The end behavior of a quadric function be described with both ends opening up if the leading coefficient is positive, and both ends opening down if the leading coefficient is negative. Very similar to our parabolas. The variations of the curvature may occur in different quadric functions, but these are the only possible end behaviors. The graph of a polynomial function. The graph of a polynomial function of n degree has n minus 1 turning points. So we saw that the cubic function could have, that was at the most n minus 1 turning points. The cubic function could have 0 turning points or 2 turning points, 2 being 1 less than 3. The graph of a polynomial function of degree n has at the most, again the most, n x-intercepts. Those are the solutions, what make the equation equal 0. The end behavior of the graph of a polynomial function with an odd degree can be described as one end opening up and one end opening down, just like the cubic function. The end behavior of the graph of a polynomial function of even degree is both ends opening up, like a quadric function, or both ends opening down as a quadric. Here's a summary of all the different types of function. Linear functions, of course, give us a line, and it's opening up if ax squared plus b if the a is positive, down if it's negative. Our quadratic function opens up or down. Our cubic function, here, opening if the leading coefficient is positive, we go positive to the right. If it's negative, we go negative to the right. Our quadric functions, here's a variety of different ones, what they might look like. Positive leading coefficient, these are up at both. Negative leading coefficients, these are down at both. Notice the number of turning points. Of course, a linear function does not turn. A quadratic function has 1 turning point with our parabola. A cubic has 2, or has 2 or 0. So here's a 0, here's a 2. A quadric function with fourth degree has either 3 or 1.